Okay, let's do this. Next lesson, 222. What can rate of change represent? By the way, we are skipping lesson 221. As much as I love the lesson, we unfortunately cannot do it because it requires some technology and some interactions that we just can't do due to COVID. So unfortunately, we're skipping it. So we're just jumping straight to 222, rate of change. Today, you will focus on the meaning of rate of change in various situations. What does a rate of change represent? How can you use it? As you graph the results of a competitive tricycle race, oh yeah, think about how the participants' rate of change compare to each other. So I don't know how many more times I can say rate of change, rate of change, rate of change. Let's move on here. So here it is, 253, the big race, heat number 1. Before a big race, participants often compete in heats, which are preliminary races that determine who competes in the final race. Later in this chapter, your class will compete in a tricycle race against the winners of the preliminary heats. No, I would love to actually pull out tricycles and do this, and I've actually done this in the past. We've actually ridden tricycles in the circle drive, which is really fun. Unfortunately, again, we can't quite, but think about it. Tricycles, that'd be pretty cool. In the first heat, Leslie, Kristen, and Evie rode tricycles towards the finish line. Leslie began into starting. Oh, I'm sorry. Hold on. Before we go there, pause. Don't pause, but pick a competitor. Who do you think will win? Leslie, Kristen, or Evie? Okay, Leslie, Kristen, or Evie. I want you to write it down on your paper. Who do you think is going to win heat number 1? No cheating. Just write it down, just for fun. Okay. Leslie began at the starting line and rode at a constant rate of 2 meters per second. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Evie rode 5 meters every 4 seconds and got a 6-meter head start. Okay, keep that in mind. On neatly scaled axes, graph and then write an equation in terms of x and y for the distance Leslie travels. Let x represent the time in seconds and y represent the distance in meters. Then do the same for Kristen and Evie using the same set of axes. Okay? Ladies and gentlemen, that's the information we've gotten. That's what we're going to do. We're going to make a graph in which we include this data. So your task is to create a graph. Now, before we do that, I do want to focus on one more thing here. As you're looking at the stuff right here, I do feel this is an important thing to mention. We'll come back in just a second. So, first of all, based on our information, the very first question you need to have is what quadrants do I need? Do I need a 1-quadrant graph or a 4-quadrant graph or a 2-quadrant graph? Well, based on this information, it does appear, look at all this right here, does appear that all I need is some positive numbers, so therefore I would just use a 1-quadrant graph. Now this graph, I am not joking when I tell you this. I am not merely suggesting. I am telling you, I want this graph to be half a page at least. I want it to be a decent size to where you can actually write the data and see it clearly, okay? So please make sure that your graph, 1-quadrant graph, is using the bulk of half a page of graph paper. Okay, I'm going to use this information right there. Okay, now, a couple things. If you haven't already noticed, all graphs must have arrows at the ends. All 4 coordinate graphs or 1 coordinate graphs need to have arrows at the end. They must also have x and y axes clearly labeled. Some of you lost points on the test because of that. I will take off points all year long if you do not do that. So please make sure you include that. Now, we also want to start at point 0, 0. You should have labels. We should also even have a title. So heat 1 race or tricycle race. The more information you have, the better it is, okay? Now, let's look at some numbers here. We're talking about 2 meters every second, 8 meters head start, 5 meters, 2 meters every 5 seconds, 5 meters every 4 seconds with this 6-meter head start. So think about that and what you want to do. Now, the problem we're facing is how big do we need to go? And we need to go fairly big to where we can include some data. But this is where that's kind of not set up well. And I do want to give you just a heads up here. Looking at the next problems, which you are going to finish answering, if the race is 20 meters long, who won? So when we set this up, we do need to set it up in a way that we can figure out how big we need to go, and we need to go at least 20 on distance. Now distance, is that going to be on the x-axis or y-axis if we're talking about how fast they're going and all the time that's happening here? Well, did it say? Oh, yes it did. Look at that. Where let x represent the time in seconds and y represent the distance in meters. So time is going to be down here, and that's in seconds. And distance is going to be over here, and that's in meters, okay? Time in seconds, distance in meters, all right? So let's put that down because I'm not going to have enough room there. I need to, for my distance, I need to go to 20. Now looking at my scale, do I have enough? I think I have enough to go for every square to be worth 1. So 2, 4, 6, 8, 10. Oh, I don't. Okay, so you're going to have to, based on your information, guys, you're going to have to figure out, ladies and gentlemen, how big do you make your scale? Now, since I am going to modify this to make it work that way. So here we go. Boom. I'm going to fit it on there because it does matter, and it's going to make, you can probably extend your line. I really can't. So I'm going to take up my whole space right here. Boom. All right. So now, 2, 4, 6, 8, 10, 12, 14, 16, 18, and then all the way at the top is 20. Okay, let's fix this up here so it looks a little better. Erase. So please take your time, and as I'm doing this, you should be taking time to set up your axes, okay? Now we also need to talk about the time. Now we don't necessarily know the time that it's going to take, and so we are going to have to, we're going to have to kind of give it some guesses here, okay? So I'm going to group that. You should not have to make a table, even though you could. We don't have to. So I don't know, what do you think a reasonable amount of time would be? Maybe 20 seconds, 30 seconds? Well, looking at the data, and try to figure out 8-meter head start, 2 meters every 5 seconds. If it's, think about how much you're going to do. So let's go to 20 seconds. Let's see how long that would go, okay? All right, so here we go. 2, and I'm going to basically do the same thing. 2, 4, every square is worth 1. If you made a scale big enough, you should be able to do the same thing. A graph big enough. If you didn't make it big enough, then you're going to run into a problem with that. Ooh, let me see. Look at that. Oh, yeah. I can cheat there a little bit and make sure I extend it to where I can actually put all the data in there because I need to go all the way to 20. Okay? All right. And so your task is you are going to actually then graph the data. I want you to look at the information that we've got here. Okay? I'm going to work on the first one with you. Leslie, and it says, Leslie began at the starting line and wrote at a constant rate of 2 meters every second. So if I start at the starting rate right here, starting line, and go 2 meters every second, that would give me there, 1 meter, 1 second, 2 meters, 2, 2, 2, 2, 2, 2, 2, 2. And you want to basically, everyone, you should be able to use up the bulk of your space. So it shouldn't be this going on to like 40. You want the majority of your space filled up. Again, 75%, probably 75% of your graph should be filled with data. This right here is a little packed in there. So we'll see if the other ones get a little bit farther spread out. I do connect the points because we can find all the values in between. The race does end at 20, so I don't necessarily need an end point or an arrow at the end. It actually has a start and a stop. So I'm going to stop right there. Okay, I'm also going to identify this as, this was Leslie. So you can either make a key, like over here, Leslie, and use a different color for the other two competitors, or you can label the actual line. But your task is going to be to finish this graph. Okay, so the video is pretty much done here in just a second. You're going to finish this graph, including the data for Kristen and for Evie. And you can pause the video at this point if you want to. Look at this. Kristen got a 8 meter head start and rode 2 meters every 5 seconds. Evie rode 5 meters every 4 seconds and got a 6 meter head start. So you might want to pause the video and write that information down because you're going to need it. Otherwise, you can find it in your book on problem 253. Okay? So you're going to do that. Then you're going to have it on your graph. And then your task is to finish answering these questions. A, B, C, D, and E. Okay? You can pause the video here if you want to and look at the questions after you're done with your graph. So you can use this. You can go back to it. I don't care how you do it, but you need to have these questions answered by tomorrow. And we're going to continue with this tomorrow, and hopefully it goes pretty well. So please make sure you have this data. I want a beautiful graph tomorrow and these questions answered. Got it? All right. See you then.